Welcome back, everybody. This video we're going to be talking about solving systems of equations with the substitution method. The substitution method, you isolate one variable, plug that quantity into the other equation, and then figure out this system from there. This question we're just going to focus on one at a time. Let's just find the x-coordinate of the solution. Now we could graph these, and graphing using Desmos.com is a great way to graph systems of equations. You could graph them, see where they intersect. We're going to do this by hand. What we're going to do first is that first equation. I'm going to get y by itself, and the way we're going to do that is add x to both sides. So y equals 9 plus x. 9 and x are not like terms, so we cannot add them together. So now I have this quantity 9 plus x, and I'm going to substitute it in for y in the second equation. So let's work on that second equation here. 10 plus 2x equals negative 2 times y. So y was right here, but I'm not going to use y. I'm going to use 9 plus x because I solved for that in the first equation. Alright, let's simplify and solve this equation and figure out what the x coordinate is. I'm going to distribute the negative 2 to the 9 and get negative 18. We're going to distribute negative 2 to x and get negative 2x. Now we're going to try to solve for x. Let's get all the x's to the left. I'm going to add 2x to both sides. I also need to get numbers to the right. So I'm going to subtract 10 from both sides. Subtract 10 here and here. 2x and 2x is 4x. Negative 18, negative 10, negative 28. Notice the other terms cancel out. Now I'm going to divide by 4. And then x is equal to negative 7. Alright, so we were just asked to find the x-coordinate here of the solution. If we want to find the y-coordinate, we can just take this negative 7 and put it right here. And we would find y to be 2. That's not this one is asking. Now the next one's going to ask for the y-coordinate. Notice the y is by itself, 2x plus 14. And I'll substitute that in for y right here. So I'm going to rewrite that second equation. Okay, y was right here. I'm not going to use y though. I'm going to use the quantity 2x plus 14. This negative sign gets distributed to each item, so we have a negative 2x and a negative 14. I'm going to have negative 6x. Negative 6x, negative 2x is negative 8x. I also need to add this 14 to both sides. And that's going to give me 18. That's going to give me 18. And just realized I made an error here for some reason. I made that this right here a 6. This should be a 4. Alright, and negative 4x and negative 2x should be a negative 6x. Let's make that a negative 6x. Now, dividing by negative 6 will give me the x-coordinate. We find x to be negative 3. I'm going to take this negative 3 and go all the way back up here, substitute it in here, show that work here. Y is equal to 2 times x plus 14. X was right here. I'm not going to write x though. I'm going to write the negative 3. 2 times negative 3 is negative 6. And negative 6 plus 14 gives me 8. The y coordinate of this solution is 8. Alright, now let's work on solving a system altogether and find the x and y coordinates. Y is by itself. I'm going to take what y equals, substitute it in right here. So I have 5x plus 2y equals 7. y was right here. I'm not going to use it though. I'm going to use the quantity x minus 7. Distribute the 2 to get 2x minus 14. I have 5x. Alright, 5x and 2x makes 7x. I'm going to add the 14 to both sides as well. Trying to solve for x, solve for a variable. And 7 plus 14 is 21. We're now going to divide by 7. 21 divided by 7 is 3. Alright, so we now have x equal to 3. I'm going to take the 3, substitute it back up here, show the work here. Y is equal to x minus 7, but I'm not going to use x. Nope, I'm going to use 3. 3 minus 7 is negative 4. Putting it together, the coordinates of the solution, 3 comma negative 4. If we were to graph this equation, these two sets of linear equations, we would see the intersection happening at 3 comma negative 4. And you can certainly try that out on Desmos if you like. Let's look at another one here. Y equals 3x minus 4. Take what y equals, y have variables by itself, and just put it in for y in the second equation. 9x minus 3, y equals 14, and then y was right here, but not going to use y, going to use the quantity 3x minus 4. Going to distribute the negative 3 here, that'll give me a negative 9x, positive 12, I'm equal to 14. So something interesting happens here. Notice the 9x's. 9x positive and negative cancel out, and I'm left with this statement saying 12 is equal to 14. That is not a true statement. That is not false. So when this happens and the variables cancel out, we say this. We say no solution. If we were to graph those two lines on a plane, they would be parallel. Parallel lines do not intersect. Therefore, we cannot find a point of intersection and a point of the solution here. Now, if this were a true statement, let me add this. If it were a true statement, say it ended up with something like 12 equals 12, we would say that is a true statement, and the answer would be all real numbers. But that's not what we got. We actually got no solution. This system here does not have a solution. Let's try one more, and notice we have different variables, m and n. I'm going to solve the second equation for m. So let me rewrite that here. M minus n equals 3. Let me add n to both sides. M is equal to 3 plus n. Take 3 plus n. I'm going to go back to the original equation. Original equation had an m right here, but now I know what m equals, so I'm going to use the quantity 3 plus n. Alright, so we have n plus n to get 2n. I'm going to take away this 3 from both sides. Equals 2. I'm going to divide by 2. And that gives me n equals 1. I know n equals 1. If n equals 1, I could solve for m. 3 plus n, but I'm not going to use n. I'm going to use the number 1. M is equal to 4. So I can write these as coordinates. 4, comma 1. Instead of x, y, m, comma n. And that's our solution to this one. Thank you for watching. Hope this helped.